Okay, good morning, 5 Science 2. This is our second lesson. I see you this week. This is the third week where we have our online lesson. Okay. So I hope everybody doing fine out there. Okay. All right. I would like to continue our revision questions. Okay. So I show you the paper now. I share with you. Can see the paper or not? Can you all see the paper? Kai Kwan, can you see the paper? Ha Kwai
Can, sir, can.
Can. Okay, come. Let's start with this question. This question is on water pressure. Diagram show a public water tank. This is a public water supply tank. Supply water to the flat. You can see here near the flat on top here got another water tank, So meaning that this water supply system is supplying the water to the houses here and also to the flat. You can see here most of the water tank they put in a high place, You see here, put on the top. This one also put on the top. This one put on the top. Okay, the reason is to get higher pressure Because when you put the water on a higher place, so the water will have higher pressure. Okay, now, first question. One factor affecting the pressure in a liquid. Okay, water pressure is affected by what? One factor affecting the water pressure is what?
Depth.
Depth. Yes, correct. Very good. Depth. Beside depth, what else? Density. Yes, correct. New said density. Chan Yi-Chin said density. Chan Yi-Chin give two answers. Depth. Correct. Okay. Both answers can be accepted. So you see the answer. Depth. Okay. So it's here. Hold on. Let me take out a pen first. So it's either depth, density, or gravitational also can, So 1, 2, 3. Acceleration due to gravity also can. Okay. So there are 4 options here. We affect the liquid pressures on depth, density, acceleration due to gravity, or gravitational field strength. Okay. Yeah. So this one settle. The second question. Calculate the water pressure at X. Where is the X? X is here. So you are asked to calculate the water pressure at X. How to find it? How to find the water pressure at X? You're given the depth here or not?
H rho G. H rho G.
H rho G. So you need to get the H, H don't have, then how to find? Yes, correct. The formula is correct. Okay, come, we see the formula first. So the pressure is rho GH, density, gravity, and the H. Okay. Density is 1000. Gravity 9.8. H is 10. I think the height is 10. In the diagram, the height of the house is 10 meters. So you just take this value, rho GH. Gravity, you can also take this one as 10. Okay, 9.8 or 10. So you get the answer 98 kilopascal. This 10 is here. Come, let me explain to you. It's referring to here, 10. 10 meter is here. The diagram not clear. This is 10 meter. Okay, can you make a note here? This is 10 meter. This, because at point X, at point X, So the depth of the water is 10 meter. From here to here is 10 meter. So label here 10 meter. Label on the diagram is 10 meter. From here to here is 10 meter. Okay. Some 10 cm not correct now. 10 meter. When you're calculating the pressure at point X, right, you take the depth here now. The depth of the water is 10 meter. Okay. 10 meter is here now. Please add now. That's why the answer is rho GH. The depth is 10. So you get this answer. Okay. Next question. Tenants on the 5th floor of the apartment block are unable to obtain the water. Why? It's because low pressure lah. This is common sense lah. You cannot get the water is because of low pressure. Okay, low pressure. So the answer is low pressure. The water pressure is low. That's the reason. Okay, low pressure. Cannot get the water means low pressure. Okay, next. Suggest explain modification to the water distribution system. Ensure the following: sufficient water supply to all areas. So what is our modification here? Suggest and explain the modification to the water distribution system in the diagram and make sure the water supply is sufficient to all areas. So what you must do, you can see here, what you can do. First thing, I will say this water tank is too low. You should get a higher one. Put it higher and use a bigger tank, correct not? Okay, see the answer. The water, okay, strong and big tank. Use a big and strong tank. The reason is volume of water is enough for all people. Okay, use a strong and bigger tank. The tank must be stronger and then must be bigger lah, because you need to make sure everybody get the water ma. So you must have a bigger tank. The reason is because more water is enough for everybody. Okay, so that's our suggestion and reason. Strong and big tank. The reason is volume of water enough for all people. Okay, all right. Next one. Next one is water supply reaches the 5th floor. Okay, so to make sure the water can reach the 5th floor, definitely you need higher pressure, correct not? Okay, so the suggestion is position of water tank must be higher than the apartment building. You want the water to reach the 5th floor, right? The position of the water tank must be higher than it. The reason is create sufficient high pressure. Okay. Position of the water tank, you put it higher, must be higher than the apartment, right? The reason is to create higher pressure. Okay, so that the water can reach. Okay, finish, everybody. For those who just came in, like Sanjeev for this, please send your attendance. Sanjeev, where's our good friend Kuhan? I never see him. Okay, come. Next question. This one I think we have discussed, correct not? Have you discussed this one, Kai Kwan? Discussed already or not? Vanessa, have you discussed this question, Vanessa?
Yes.
Discussed already, huh? Okay, then this one also discussed, right? Vanessa?
Yeah.
Okay, come. Then This one, this one not yet. I think this one not yet. Correct not, Melissa? Please help me check.
No.
Then we come here lah, huh? Okay. Okay, come look at this question now. All right, this one is something to do with elasticity. Okay. Diagram show a boy pulling the rubber cord of a catapult. Okay. Elastic cord of catapult. This is a catapult now, huh? By the way, you all have this question on your paper or not? Pong, do you have this question on your paper?
Yes, yes.
Okay, thank you. Okay, so you can see here when the boy pull the elastic, right? Pull the rubber cord and then release, then the stone will fly very, very far. Correct not? Okay. The reason is that because when the boy pull the elastic cord, so you have elastic potential energy. This elastic potential energy, when you release, if you bring the stone go to a very far distance, see the energy changes that take place from the instant the stone is released until the stone reaches the maximum height. Okay. Can you tell me what energy change to what energy there? From the instant the stone is released, that means start from when the stone is released until the stone reaches the maximum height. So start with what energy to what energy there? Anik, are you there? Anik?
Yes, sir.
Anik, can you try? The stone from the instant when the stone is released, when the stone released until it reaches the maximum height, what energy to what energy? Try, just try, Anik.
Potential to kinetic, sir.
When the stone is released, started from there, you know. When the stone is released, it starts with what energy there? See from here, when the stone is released, so the stone started to move, then go to the higher place. So started with what energy here?
Elastic potential energy.
When the stone started to move, Anik.
Don't know, sir.
When a stone started to move, means it's already kinetic energy, right? Started to move, kinetic energy. Then some more you go higher, higher, higher is what energy? When a stone go higher is what energy lah? Pong. Start moving is kinetic, kinetic, kinetic. Then when you go higher, so it become what energy?
Gravitational potential energy.
Yes, correct. Gravitational potential energy. Okay, come check the answer. No answer. Very sad, no answer. Okay, no answer. Never mind. You all listen to my answer lah, huh? Okay, so you write start from kinetic energy to gravitational potential energy. Write the answer. Start from potential energy. No, sorry, kinetic energy. Kinetic energy. Kinetic. Then to gravitational potential. Gravitational potential energy. Okay. Kinetic energy to gravitational potential energy. Okay. Start from kinetic energy, then you get gravitational potential. Got the answer or not? Anik, do you get the answer?
Yes, sir.
Okay, okay. Richie, because the question say, from the instant the stone is released, start from when the stone release, Richie, that's why no gravitational potential. No, sorry, no elastic potential. From the stone is released. So once the stone released, straight away kinetic energy already. Richie, understand? Okay, next question. Okay, Richie, understand? Name the physics principle. What principle? This energy change to this energy. What principle is that? Okay, write the answer. Principle of conservation of energy. Principle of conservation of energy. Okay, jot it down. Principle of conservation of energy. The energy is conserved. It means the energy is changed from one form to another form. We call it principle of conservation of energy. Okay, got it? All right, next. Each rubber cord requires 16 Newton to pull the stone backward by the distance of 20 cm. Each rubber cord, needs 16 Newton, 16 Newton. Now you have two rubber cords, you see. Okay, how much energy stored in both rubber cord? Okay. How to find the energy there? Elastic potential energy. Okay, use this formula now. Half what? What formula? Pong what? Pong Cherry. Elastic potential energy what formula? Someone answer. Neil say half kx square. Barack Obama say fx. No half one half fx. Okay. Yes, we use a formula half fx. Okay. Another formula is half kx squared, but k cannot use here because no k given, no spring constant. Only given you force and extension. So we use this formula. Okay. I keep quiet first. You go and calculate the answer. I'm sure some of you make mistake one. Please calculate and then tell me the answer later. Use the formula. Someone already give the answer. Come, let me see. Vanessa say 160. How many of you agree 160?
Me.
Anik agree. So two of you got 160. Anyone disagree? You all can see the answer in the check box lah. Okay, your friend give one the answer 160. But I don't want to say it's correct or wrong first. So far, Anik. Now this Richie says 16 only. So much different. Vanessa say 160, but Richie says 16. So which one is correct? Okay, let me tell you. Okay, come. One more student give answer. Kimberly say 160. Kimberly. Okay, this was what I worry about. Student, just now I already said student will make mistake one. Is it proven already student make mistake? This Barack Obama now say 1.6 pula. 1.6.
The centimeter should change to meter.
Yes, correct. The X must change to meter. Yao Ping say correct. Change to meter. The science student always make mistake one. That's why I say quiet first. The extension must change to meter. Force is 16 Newton. Right? X 20 cm cannot put 20 cm on. You must change to meter. So it's 0.2 meter. And now, what is the answer? Yeah, remember, no. Don't make this stupid mistake anymore. Okay. So what is the answer?
6.
Huh? 1.6. 1.6. Okay, I think it's 1.6. 1.6. Energy. Energy new is joule. Okay. 1.6, is it correct? Check, use your calculator to check. And then correct or not?
Correct, sir. 1.6.
1.6 joule, energy. I'm sure some fellow go and put Newton one. Not Newton, energy is joule. Okay, next. If the stone has a mass of 40 grams, calculate the initial velocity. How to find the initial velocity? Meaning that the moment the stone started to fly, so what is the velocity? Okay, this question is supposed to be like this, What energy make the stone fly is because of the elastic potential energy. This energy lah. So elastic potential energy will change to kinetic energy when the stone fly, right? Not kinetic energy formula is half mv squared. Okay. Use this formula, you go and find the V. This elastic potential is 1.6. You can take from here. 1.6 equal. Okay, do yourself. Find the V. Mass change to kilogram. Once again, no, don't use 40. Mass must change to kilogram. Do it yourself, please. And then tell me the answer. What is the velocity? My writing very ugly. My computer don't have touch screen. That's why I have to use a mouse. You move the mouse to write very ugly. Sorry. If you have money, go and buy a touch screen computer. So one answer. Okay, I continue a little bit now. 1/2 mass change to kilogram. 40 divided by 1,000. So it's 0.04, I suppose, divided by 1,000. So you find the V. Two students give the answer already. Okay. Both of them give 8.94. Chan Yijin 8.94. Michelle Chua 8.94. When you all check in the checkbox, see the answer correct not? You get the answer 8.94. Anik also say 8.94. Is it correct? Yes, the answer 8.94. Correct, 8.94. Many of you keep already. Unit must write also. Meter per seconds. Okay, Chan, you are right. Chan Yijin. So the answer is 8.94. Come with the unit, meter per second. Okay, that's the answer. 8.94 meter per second. All right. Next. This question, have we discussed? Vanessa, have we discussed this one? The next one?
Yes.
Discussed already, huh? Okay. So this one all finished or not? Okay, come, we move on, huh? This one, I think not yet. Correct or not? Vanessa, this one not yet, huh?
Yeah.
Okay, come, we look at this question. Water pressure question again. Diagram show the position of two fountain. Got two fountain. Here got one fountain, water fountain. And here got another one. The water shoot out water fountain. The water fountain get the supply of water from the big tank on top. So high pressure water will be sent here. So the water shoot out. And then here the water shoot out again, right? Okay, now the question. Work by using pressure and receive water supply from the same water tank. Okay, X is a water level. X is a water level here in the water tank at 9 a.m. Early in the morning, the water level is here. And then later on, you see the water drop already, right? Okay, now what the question say? Compare the height of fountain M and N. This one normal. Of course, this one higher than this law, correct not? So the height of M greater than N. So your answer is M bigger than N. Just give the answer like that. Okay. The height of the fountain M greater than the N. Okay. So this one no problem. All right, next. State the relation between the height of the fountain and the water pressure. Height of the fountain. Relation between the height of the fountain and the water pressure. How do you think? Someone give the answer. Come, let's check the answer. Chan Yijin said, the greater the height of the fountain, the greater the water pressure. Agree or not? Okay, I want you all to see the diagram. Which water fountain, the water shoot out higher level? You see carefully. M or N? Which one the water shoot out higher? N, right? N shoot out higher. You see the water here shoot out higher, means actually here the water pressure is higher, Because the water higher, right? You shoot up higher, Here the water shoot up lower. So now check again the answer. Firstly say like this, the lower the pressure, the greater the height. The lower the pressure, the greater the height. Firstly, your answer is correct, but terbalik. Which one should come first?
Height.
Yes. Okay, you see this one is higher, but the pressure is lower, correct not? So your answer should be, now terbalik again, give answer. The height increases with the depth because point pressure in liquid increases with the depth because point greater the height, point greater the weight of liquid above it. Kimberly say low, sorry. Okay lah. The answer given by Anika, Kimberly partially correct now. Okay, so your answer should be like this, because they ask you to state the relation between the height and the water pressure, Okay, so you say like this, the greater the height, the lower the water pressure. Here is height, very high, but the pressure is lower. You can see here. The greater the height, the lower the pressure. Height here refer to the height of the fountain, not height of the water, you know, the height of the fountain. The greater the height of the fountain, the lower the water pressure. Okay? Let me explain why. The reason is here, you know, you all listen. Actually, how high this water can shoot out is depends very much on the water pressure. Okay, here you see, at this point, the height is here. The water depth is count from here, you know. I mean, the water is not so deep. But for this level, you draw a line. I see the depth is very much deeper. It's deeper, isn't it? Deeper. Here, that's why here water pressure is higher. The depth is count from the water surface until this level. This level is here, now the depth is here. So this is not deep. Not deep means pressure not high. And this point, it is deeper. The water from here to here is deeper, so it's higher pressure. Understand? Please jot down the diagram now. Here, not deep, this one deeper. This one here supposed to be higher pressure. Jot down the diagram, even though my diagram very ugly, but I think you all can understand now. Pressure in the liquid increases with the depth because deeper the point, greater the weight. Yes. Next, this one is correct now, but you are not answering the question, you know, honey. You need to answer the question. The question asking relation between the height of the fountain and the water pressure. Okay, so our answer is the greater the height of the fountain, this fountain is higher, but the pressure is lower, not because the depth here smaller, so it's lower pressure. Okay, got the answer. Okay. Okay. Then next, calculate the water pressure at N. N is here. Calculate. N is here. It's not enough information here. Can you add the information here now, please? Okay, add. Okay, you draw a line here, everybody. Draw a line here. Add information. If here is 16 meter, okay, you put here 40 meter. 40 meter. Okay. Now you can calculate already. What is the pressure at point N? Can you find? At here 40 meter here 40 meter, here 16 meter. So can you find the water pressure of point N? Use this formula, water pressure P equal to, like just now someone say rho H G. Okay, calculate now. Next say 240 kilopascal. 240. Give it first. See whether correct or not. The rest, please calculate. Okay, raw water density water is 1,000. 1,000 10 power 3 H. What is the H then? If you want to find the pressure here, what is the depth of the water? Kai Guan, Cha Kai Guan. What is the H value? Cha khai quan. Tan 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 yin si, tan xing si. Tan, can you come out? Tan xing si.
24.
24. Yes, correct. 40 minus 16, so it's 24. Okay. Gravity is 10. Okay, I think our next answer is correct. 240. So what is the answer here? Is it 240,000? Like Anik say? Anik give the answer 240 kilo. So our answer is what? To give in standard form 2.4 10 power what? 2.4 10 power what? What is the value first, Chan? Ten power 5. Shakira say 10 power 5. Yes, correct. 10 power 5. Okay. And unit for pressure is Pascal. PA. Pascal or Newton per meter square. Chan, you're correct. Newton per meter square also can. But that normally we put Pascal So these are answer 2.4 10 to the power 5 Pascal. Yeah. Okay, next. At 4 p.m., the water level has dropped from X to Y. Drop from X to Y. Here to here, drop to X to Y. Okay. Based on a diagram, compare the water pressure at M and N in the afternoon with that in the morning. Okay, definitely the answer decreases the water pressure decreases. Okay. Compare the water pressure at M and N in the afternoon with that in the morning. So the answer is water pressure decreases. Water pressure decreases compared to in the morning. At both points, water pressure will decrease. Because what is the reason, Nick? What is the reason water pressure decreases in the afternoon? Kimberly? Kimberly, please come out, please. What is the reason water pressure decreases? Vanessa, can you answer?
Temperature increase.
What again? Vanessa? Kimberly give answer level of water in the tank decreases. Yes, correct. Yeah lah, because you see, the Kimberly answer is correct lah. Because in the afternoon, the water level dropped already. When the water level drop, it will affect the depth of the water, correct not? It will affect the depth of the water, ma. So in the afternoon, the depth decreases. So this will make the pressure decreases lah. Okay, please write your answer. Water pressure decreases because depth of water decreases. Depth of water decreases. Depth of water decreases due to the drops of water level. Okay, water pressure decreases because depth of water decrease. Depth of water decrease due to the drops of water level. What the answer now? Okay, I want someone to read out the answer. Cheryl, you, are you there? Cheryl, you? Cheryl lah. Cheryl, Idris Young. Idris Young, can you come up, please? Idris Young.
Yes, sir.
Idris, can you read the answer?
The water level decreases because the depth of water decreases.
Huh? One more time, the complete answer.
The water level decreases as the depth of water in the tank decreases.
Okay, is water pressure decreases. Water pressure. Water pressure decreases as the depth of water decreases lah. As the depth of water decrease due to the drop of the water level. Okay, come next. Have we discussed this question?
Yes.
Discussed already, Okay, we move on. This one also discussed. Vanessa, please confirm. Have we discussed this?
Yes.
Also, okay, good. This one?
Done already.
Done already. Okay. Yeah. And now electricity, correct not?
Yeah.
Okay, come lah. We do slowly lah. This one, Come, okay. Last few minutes only. Pay attention, everyone. Diagram show a photograph taken from a river tank. This is a river tank. See the water lah, river tank, right? To investigate the patterns of water waves. See the pattern, okay? The frequency is 20 hertz. Frequency of vibrator. The vibrator is here vibrate. Then you see the water wave come out, right? Now, what is the meaning of frequency? Frequency is what? What is the meaning of frequency? Think of the answer, everyone. What is the meaning of frequency? What is the meaning of frequency? Number of complete oscillation made in the units of time. Yes, correct. Now is here. The answer is here. The number of complete oscillation in 1 second. This is frequency. Number of complete oscillation in 1 second. Okay. Number of complete oscillation in 1 second. This one is frequency. Okay, next. The distance between AP is 5 cm. Here to here, 5 cm. See the diagram, AP. What is a wavelength? What is a lambda? Okay. From A to B, there's how many lambda here? How many lambda here? Idris Yong, how many lambda? A to B, how many lambda? Fazli, how many lambda here? Okay, there are 2 lambda. You see here, 1, 2. So to find the lambda, you take 5 cm divided by 2. Okay, there are 2 lambda here, 1, 2. Okay, so the answer is 2.5 cm. Okay, 5 cm divided by 2, so you get 2.5 cm. Okay, Okay, next question. So here you take 5 divided by 2. In the diagram, got 2 lambda, isn't it? Then calculate the speed of water wave. Speed is V equal to F lambda. Please do the calculation. V equal to F lambda. Okay, calculate the answer. So what answer you get? V equal to F lambda. What do you get? Type the answer. Okay, show the answer. Okay, those who get the answer, please type. V equal to F lambda. Frequency is given 20 hertz. Lambda, please change to meter. Okay, you change the lambda to meter lah. You don't want to change it, so okay, but you leave your answer in cm per second. Okay. So frequency is 20 hertz. Lambda just now was 2.5 cm. I leave it as cm lah. Okay. So the answer is 20 times 2.5. So you get 50. Okay. So the answer here you put 50. But the unit is in cm, because you will never change just now. Cm per second. Yeah, good answer. 50 cm per second. Got it or not? The answer is in meter lah, 0.5 meter per second. Okay, 0.5. 50 cm is 0.5 meter lah, it's the same lah. Huh? Okay, next one. Predict the frequency if the speed increases. Speed increases. What happened to the frequency? When the water faster, speed of the water increases. When the water go faster, what happened to the frequency? Okay, the answer increases. Increases, Why is increases there? Because you see the formula V equal to F lambda. Okay. When the speed increases, right? So the frequency also will go up lah. Because it's directly proportional. Okay. If the speed increases, the frequency also becomes faster. Okay, Okay, next. Diagram show a simple transformer. This is a transformer. Primary coil, secondary coil. Okay. Primary coil, you have 240 volt, 240. And then output, the secondary coil become 9 volt. So it step down. Correct not? It step down. Now the question. Have we answered this question? Vanessa, have we discussed this?
No yet.
Not yet, Okay, what types of transformer is this? Step down, correct? Not step down transformer. Okay, step down transformer. Okay, step down transformer. Step down transformer. Okay, next. Why is soft iron used? Why use soft iron here? You all should know the answer now. The reason of using soft iron is easily magnetize and demagnetize. Yes, correct. Shakira, you are right. So the answer, soft iron can be magnetized and demagnetized easily. Okay. This reduces hysteresis loss. Okay. Hysteresis loss. It can reduce a hysteresis loss. Okay, this one finished. Iron, soft iron can be magnetized, demagnetized easily, reduces hysteresis loss. Huh? The next question. Why is called laminated? Why need to laminate? Laminate means one layer lah. Why need to laminate? The answer is to reduce the eddy current. Okay. Reduce loss of energy caused by eddy current. Okay, caused by eddy current. Yeah, got the answer now. Jot down quickly. Reduce energy loss due to eddy current. The next calculation. If the secondary coil 120, calculate the primary coil. Got how many? Okay, so you see here now. NP, if secondary coil 120, so here is 120 tons. Voltage is 9. So they ask you to find how many tons here. So use this formula. NP, NS, VP, VS. Okay. NP to know. NS 120. VP 240. VS 9. So you get 2,300. 3,200. 3,200 tons. Okay. And the last one, find the power. P equal to VI. Use the formula VI lah. Voltage multiply current 2. Yeah. Okay, the power, you got the formula. If VP equal to VI, you got the answer now. Okay. Okay, next. This one is the last already lah. If the efficiency of transformer is 90%, calculate the current flow in the primary coil. Okay, what formula? Efficiency 90%. Calculate the current flow in the primary coil. Okay, the formula is efficiency, EFF, efficiency equal to output power, the power output, divided by the input power, PI, okay, times 100%. Okay, use this formula to calculate. Okay. Efficiency given 90%. So here is 90. Okay. 90. The output power you calculate already 18 watt, correct not? 18. Just now 18, right? And the input power is VI, voltage is 240, correct? Not 240, huh? VI. So I, you don't know, you ask to find the I. This one VI now, time 100%. Okay, find the I, please. Find this I. Input power is VI, 240 volt times the current. So you find the I. Okay, please solve the equation. Yao Ping, have you get the answer? And Yao Ping can get the answer or not? Yao Ping. Yao Ping, where are you? Anyone got the answer? Please type the answer. Please type the answer if you got it.
More. 1/12.
1/12. Okay, come, let me check. Yao Ping say 1/12. Just now, Vanessa also say 1/12. Yes, the answer is 1/12. Okay. Yes, 1/12. I calculated also 1/12. Yes, correct. Okay, you check the answer. Here lah. 1/12, 0.083. Okay. So okay, I write the answer here now. So I is 1/12 ampere. 1/12 ampere or 0.083. Okay. 1/12 ampere. Okay. Okay lah. So I have to stop here lah because I'm sure you have another lesson later on. What lesson you all have after this? 11:30. What lesson you all have?
Sejarah.
Sejarah. Okay lah. So I stop here for today now. I stop sharing already. Got the answer. Okay, 5 science 2. Anyone haven't sent your attendance? Can you please send it now before I stop? All send already? Send your attendance already? Okay, so 5 science 2. Thank you for joining this lesson. Thank you very much.
Welcome.
Adi baru hantar lah. Anyone who haven't sent or not, because once I stop already, you cannot send already now. You better send now. Those who haven't sent your attendance, please send in now. Okay. All right. So thank you very much. Take good care, everyone. Okay. Stay focused. And I see you next week. Okay. Next week, I see you again. Okay. Bye-bye. 5 science 2.
Yeah.
Bye-bye.
Thank you, sir.
Bye-bye.
Thank you, sir.
Yes. Bye-bye.
Yeah.
Yes. Bye-bye.
Thank
5
you,
science
sir.
2.
Thank you, sir.
Thank you, sir.
Bye-bye. Bye-bye. Yeah.
Thank you, sir.
Okay. Bye.